Hi everyone. Today we are discussing characteristics of quadratic functions. In other words, we're talking about the parabola, and it has characteristics just like our linear functions, except it has more. So we're going to start off with one equation, y equals x squared minus 2x minus 8. And here we have drawn a graph. You can see that it has this really nice parabola here. You can see that it has x-intercepts, it has a y-intercept, and down here at the very bottom where it makes a turn, okay, this is where it has the vertex. So the vertex is located right here at the bottom. Okay, so we're just gonna write that in right here, that, oops, that this should be, in fact, the vertex right there. Okay, now this vertex will also tell you whether you have a maximum or a minimum. So at this vertex, because it is the lowest point of the graph, this is called a minimum. Okay, a minimum, because it is the lowest point. Okay, so also what happens at this vertex is we get this line of symmetry. If you remember, we've talked about reflection lines before. Okay, this reflection line right here, which is the line that cuts it in half, okay, this is the axis of symmetry, or they call it the line of symmetry. Okay, so the line of symmetry is at x equals 1. It is always an x equal value, x equals 1. The vertex, what is the coordinates of this point? This is 1, -9. So 1, -9. Y-intercept, right here on the y-axis, where does it come across? At -8. So that is the point 0, -8. The x-intercepts, where does the parabola cross the x-axis? And we look, we have two locations. We have -2, so that's -2, 0. And we also have +4, so that's at +4, 0. Okay, this shape opens up, so it creates a bowl effect, and that means that this vertex is a minimum point. Okay, so these are our basic characteristics so far of these shapes. So if in fact we take it and we have a negative out front, that means that it is going to reflect down. So here you can see, instead of it pointing up, everything is pointing down here. Okay, it is sitting on right here. This vertex point is up here on the y-axis. So that means our line of symmetry is x equals 0. It's x equals 0 because it is sitting on the y-axis. Okay, so the vertex, this point right here, is our vertex. One more time. Let's write that in there so we can see that. This is the vertex, and because it is the highest point, it is a maximum point. Okay, so our vertex is 0, 4, because that's on the y-axis. Our we did y-intercepts first here. Okay, the only place it crosses is right here at the vertex, so it also crosses at 0, 4. Our x-intercepts, where does it cross on the x-axis? Here at -2 and also at +2, -2, 0, +2, 0. And this time it opens down. Okay, so we said opens up meant that we had a minimum. Opens down meant that we had a maximum. Okay, so those are our basic x-intercept, y-intercepts. So what's really new is line of symmetry and vertex. Okay, we've already discussed domain and range before, but now when we have domain and range, it differs from our linear. So you can see on the left picture, domain is still going to be all x values. So that means that our domain here is still going to be from negative infinity to positive infinity. It will be every single number because that parabola is going to open up forever. Okay, but the range, okay, the range, you can see that it stops here at 3. So the range is everything from 3 up. Okay, there's no graph down here below 3. So they've written range as y greater than equal to 3. You could also write that as from 3 to positive infinity, meaning that it's going to start at 3 and go up forever and ever. Okay, so over on the second one, this one is pointing down. Your domain is still all x values, or in other words, negative infinity to positive infinity. It's never going to change. This time the range goes from 2 to negative infinity, but we would write it as negative infinity to 2. Okay, so two different ways that you could see these ranges written. Okay, increasing, decreasing, same thing, except that with this increase, decrease, we have to watch what's happening. You always move from left to right. So in this first picture, you first identify the vertex point here, okay, or your axis of symmetry that we just talked about. And the x value, okay, the x value is what we're working on. So if this is our, let's call this negative infinity out here, and this is positive infinity, okay, and this is some value x, so it's somewhere along the line, then this decreases from negative infinity up until that x value. You're always dealing with x. So if this was x equals 4, then you would have a 4 here. Then you can see it curves and it starts going back up. So it starts increasing from this x value. So if we called it 4, it would be from 4 all the way to positive infinity. So you're looking at this x-axis when we are deciding what group is increasing or decreasing. Okay. All right, the same thing happens if it's turned upside down. You're still identifying that axis of symmetry, which is that reflection line. You're looking for the x value. And if we wrote our negative infinities and positive infinities here, so from negative infinity until it reaches x, this is the section that is increasing, that is going up. We're not looking for the point up here. We're looking for the x value. How far on the x-axis did it go? Okay, then it's going to turn and it's going to come down. So this is our decreasing section from this x value to positive infinity. This is the section of the graph that decreases. So this is all about your x values here. Okay, so here's an example. When I look here at this graph, the left side of it is decreasing. We did decreasing in red, so decreasing is in red. So if this is negative infinity and this is positive infinity, then from negative infinity to this section, okay, so this section in red right here, so it goes from negative infinity all the way to 3/4 because that is my x value there, okay, 3/4. So from negative infinity to 3/4 is the decrease. So you can see that's how we wrote it. And then it makes the turn at this 3/4 and continues on to positive infinity. From 3/4 to infinity is where it's going up or increasing. So you're always using the x-axis, never the y values, always the x values. Okay, end behavior we've talked about before. We want to know where the ends are going when we're looking at our problem. So here we know this is negative infinity, positive infinity, positive infinity, negative infinity. Okay, so as x is at positive infinity, so as I am right here, where's the closest end? Well, that's this end, and it is going up. So since this is going up, it is going towards positive infinity down here. Okay, the second line says, what happens if I am over here at the negative infinity? Where's the closest side of this parabola? Okay, it is right here. And which way is it going? Is it going up or is it going down? And you can see this is going up. So both are positive infinities here. On the linears, we had one of each. Here, parabolas either both are pointing up or both are pointing down. If they're pointing up, then they are going towards the positive infinity. If you look at the second one over here, and we'll just put our infinity symbols back on here for you. If they point down, then they both go towards negative infinity. So actually, I think parabolas are a little easier when we're talking about our end behavior. Okay, so the best thing we can do is work some of these, and we're going to roll through. We have 4 different examples, and let's see how far we can get through this. Okay, so first off, we need the vertex. The vertex is right here. Okay, so that is at 1, -4. That means our axis of symmetry is right on this line. Right here is this axis of symmetry, and that is x equals 1. It comes right through 1. So our axis of symmetry is x equals 1. This is a minimum point because it is the lowest. The vertex is the lowest point. Our x-intercepts we can see here are -1 and 3. Okay, so -1, 0, and 3, 0. Oh, sorry, that goes right here. Boop. All right, y-intercept right here at -3. Okay, so this is 0, -3. Domain. Now we already said for domain it is always all real numbers, so negative infinity to positive infinity. Range, this is going from -4 upward. So that's what we're going to tell it, -4 to positive infinity. There we go. Okay, increase and decrease. So what I'm going to do is I'm going to take and highlight this a little bit. We said the decreases were red. Okay, decreases were red. So, whoops, sorry about that. So this part's decreasing. Okay, and then the increasing we had was green. So this part's increasing. Okay, so where this thing changes, okay, where this line changed, right here, okay, that's the change. So if I'm looking at the axis here, what happens? We have negative infinity, we have 1, and we have positive infinity. So I'm going right along this x-axis. So this is the decrease. So from negative infinity all the way to 1 is my decrease. My increase, where it starts going up, happens from 1 to positive infinity. Okay, my end behaviors, what's happening on the ends, they are both pointing up. So I'm not going to write the whole thing out. You just need to know that they're both infinity and infinity. Okay, so that should be fairly simple. Okay, so let's try another example. So here we can see that we have a parabola
and this time it is upside down. So what we want to do is answer all of these questions that we have over here, just like we did on the last one. So the first thing is we want to locate the vertex. So if you remember, the vertex is where it changes direction. So it is either the highest or lowest point. Since this is upside down, it is the highest point here. And so this is at 3, 2. So you want to make sure that you're looking at the values on the actual axis here. So this would be 3, 2. The axis of symmetry then is if I cut this right down the middle, you can see it is at the x value of the vertex, which is x equals 3. This is a maximum since it is the highest point. Our x-intercepts are at 2 and 4. So that's 2, 0 and 4, 0. Our y-intercept is way down here at -16 on this graph. So that is at 0, -16. Domain, we've already said, is all real numbers. Okay, negative infinity to positive infinity. Range, though, is from negative infinity, but we have to stop at y equals 2. So up here, the top stops at y equals 2. So our range, we could say, is y less than or equal to 2, or we could say from negative infinity to 2. Okay, increasing. So the increasing is this left side here. Okay, we know that we go along the x-axis. So from negative infinity to our axis of symmetry here at 3 is going to be the increase.
And then the right half from 3 to positive infinity in this case is the decrease, because that's where we start coming back down. And behavior, both are pointing down. So negative infinity and negative infinity. Okay. With this problem, the graph was not originally there. So what I did was I went in Desmos and I graphed this equation, and then I clicked on all of these points so I can see what their values are. Now, you really only need to go to 1 decimal place or 2. You don't need to go any further than that. Okay, so here our vertex. Okay, once again, our vertex here, we've already got identified at 1, 2. Our axis of symmetry, so that is right here. Remember, it is just the x value, so that is at x equals 1. This one is a maximum because it is upside down. It has identified our x-intercepts here, so those are actually our points. So you could say 0.18, 0, and you could say 1.8, 0. The y-intercept down here on the y-axis, which happens to be at 0, -1. Domain, once again, is all real numbers. Because it's upside down, our range goes from negative infinity all the way to the top, which is at 2 this time. Okay, increasing is the left side because it's going up. So we increase from negative infinity all the way to this line here. So it is to right here, which happens to be 1. And so the decrease is on the other side from 1 all the way to infinity. And both ends are down, so we would be looking for both negatives. All right, so one final one. Okay, once again, this one was not graphed. So I went into Desmos, generated my graph, clicked on my points here. Okay, so my vertex down here, so this one is the lowest point. So this is 3, -4. That axis of symmetry is coming right up the middle. Okay, right up this middle, and that is at 3. Okay, so x equals 3. It's always the x value of the vertex. This is a minimum because it is the lowest point. It's identified my x-intercepts for me. So 1.8 comma 0, and the other one is 4.1 comma 0. The y-intercept is way up here at 0.23. Okay, once again, our domain, negative infinity to positive infinity. And the range, the lowest is from 3 all the way up, which is positive infinity. Oh, I'm sorry, not 3, negative 4. Okay, so for range, we're looking for y's. Okay, increasing. All right, so 3 is the dividing line here. Okay, so the part that's increasing this time is the right half. So the increase is from 3 to infinity. And the decrease is the left side, which is negative infinity to 3. And both ends point up, so that means they are both going towards the positive.